Well, that I guess is the kind of formal talk ended, but there's several points to say. First of all, if anybody has any questions, I would do my best to answer them. And at the end of this presentation, I'd like Jeremy Spring, Halford's step-grandson, to kind of formally present the albums to Tony Pilmer here, who's with us, who's the head of the National Aerospace Library at Farnborough, where the Halford diary is kept, so that these documents can be kept together, because together they make an absolutely wonderful resource. And I hope at some point they will also be available as an online resource, because both documents really are suitable for scanning and being available online. I've done quite a number of, obviously, digital copies of the images from the album to make these presentation images for today's talk. But clearly the album and the diaries could all be scanned and available online, and they make absolutely fascinating reading. Again, it's an era that is very hard to conjure up now, but these kind of documents convey the spirit of the age. So does anybody want to know anything more about what I've said, or ask me, challenge me something I've said? It's fair to say also that Susan Walker is writing a book, as she mentioned. And again, anybody who's got connections with the early aviation days of the Comet and the early experimental aviation work that was done. Of course, what was interesting is my civil service career started at the National Engineering Laboratory in East Kilbride, and at East Kilbride my boss was a guy called Norman Frost, and Norman Frost was one of the team that worked at Farnborough on metal fatigue, and indeed the Comet crashes was one of their first big research projects, and they carefully recovered all the wreckage of the first Comet that crashed off Rome in the Mediterranean. They collected all the pieces and brought them back to Farnborough, and they recreated the airframe, and they were able to discover how cracks had developed from the corners of the windows in the pressurized fuselage of the plane, which led, in one fell swoop, it led to windows on aircraft being made with rounded corners instead of square corners. You may note that aircraft to this day don't have square windows, they have round windows or oval windows, and that was to remove the stress concentrations caused by the square holes in the pressurized fuselage, creating cracks which caused the whole aircraft to fall apart. And Norman Frost was my boss at the NEL in East Kilbride, where I used to have discussions about metal fatigue, and the Comet crash was one of the things that they all talked about. But do any of you here have any experience of working in that sector? Are there any ex-aircraft industry people in today? Right?
I won't go into it.
You won't? You won't go into it?
What I was going to ask, which was of interest, was the relationship between Halford, thank you, and Frank Whittle. Because when you look at the Goblin, which I think was the first Halford jet engine, it actually had a rather more logical layout than Whittle achieved. You know, Whittle had a lot of trouble with his combustors.
Yeah.
I'm just wondering at what time in the evolutionary period did Halford actually get involved? I mean, he was obviously privy to the sort of the secrets of the jet engine, which not many people knew about.
Well, the early jet engines were all basically fitted with centrifugal compressors rather than axial compressors. In other words, they were basically larger diameter, and they worked on centrifugal flow rather than blades in a long line. And when you look at fitting a jet engine into an aircraft, obviously you're struck with the problem that the configuration of a centrifugal compressor is not ideal for an aircraft. And it's quite interesting when you look now at current, or not so much current, but certainly 20 or 30-year-old small jet engines are often based on turbocharger technology. And on one particular occasion I flew in a military twin-engined passenger aircraft from Northolt up to the site at Barrow-in-Furness, and we were flying in a Beech Queen Air, and a Beech Queen Air had twin Garrett Air Research jet engines, which were basically turbochargers converted into aero engines by basically fitting combustion chambers and burning fuel rather than just using exhaust gas to pressurize the inlet mixture in a piston engine. So they used the technology of a turbocharger to build a simple and cheap turboprop, and that design obviously is very like the design of the early, both the Whittle engines and the early de Havilland engines.
Well, I was going to say both the Whittle and the de Havilland engines were.
They were centrifugal compressors, yeah.
But the combustion system seems to be very different.
Well, Whittle's designs, of course, started a lot earlier than the work that Halford did. So Halford was to some extent building on what had already been flown. You know, the Whittle engines were his research. I'm not the best expert, but I'll quote what I believe to be the case. I think Whittle's work started, in fact, in the late 20s, but he really got underway seriously in the early 30s. And they set up a plant at Lutterworth, a company called Parajets, which was there developing the Whittle ideas into practical engines. And the Whittle prototype engines are all now at the Science Museum in South Kensington. And that's another interesting place to visit if you want to know more about Whittle, because all of the Whittle engines were actually kept by the National Museum of Science and Industry, the Science Museum. They're all in the National Collection at South Kensington. But the de Havilland engines were developed with the benefit of time. Of course, the metal technology was a lot improved through the war. And in fact, what seems to me to be almost overlooked is the rate of development of special high temperature materials needed for jet engines. Went absolutely apace during the Second World War. And recently I watched a very interesting technical program about the development of the J58 engines, which were developed by the Americans. Pratt & Whitney, I think, developed them for the SR-71, the famous Blackbird aircraft, which famously crossed the continent of America in 40 minutes at Mach 3. And that was back in the early 70s. And that engine is so far advanced from what was being built when Whittle and de Havilland were building jet engines as to be almost mind-boggling. And the whole J58 engine, when it's at operating temperature, expands in length by 6 inches because of the temperature of the engine. And the diameter of the engine increases by 2 inches when it's at operating temperature. And then when it cools down, it shrinks. So if you can imagine building an aircraft with an engine which basically expands and contracts in its operating cycle, it really boggles the mind. And it's quite an interesting technical documentary. You'll find it on YouTube. The technical description of the development of the J58 engine, which is a fabulous thing. And that was only literally 2 decades after Halford was working on the engines with de Havilland. But of course the engines were very successful, and indeed the engines, unfortunately, were also passed to the Russians. And the MiG-15 famously had a copy of the engine that was in the I think it was called the Neen, the Rolls-Royce turbojet that was in the early British jet aircraft, was actually copied and made for, well, the original MiG-15s were actually powered with Rolls-Royce Neen engines, and then the Russians started building them under license. And you can actually buy spare parts for your Neen from the Russians still, because the engines in a MiG-15 are an actual perfect copy of the Rolls-Royce Neen. So there was no design development required. It was take the engine apart, make copies of all the parts and put it all back together again. That's how the Russians got their jet engine technology in the early days. This particular comment may be edited out, I suspect.
Very nice talk, thank you, Martin. Very, I don't know, I like the inside of your brain must look like one of the jet engines, I should think, how you keep that information in there. Just a small thing with motorbikes. Is the Martin Jap still exist? Do any of the motorbikes still exist
Well, I have a restoration project which I brought back from Australia, which was so badly rusted it was barely a motorcycle, but the parts of it were there. But I have spent the last 20 odd years, I worked for the Australian federal government in 1993 and 1994. So I came back from Australia in 1995, or late 1994, and my parts were brought back from Australia in 1994, and I've been restoring the bike ever since. But the project is stalled essentially because I have too many other projects competing. And when you have multiple projects, you tend to work on one project, and then when it starts to clog up, you move your attentions to another project. And my Martin Jap is, I would say, 80% finished. But parts of it are replicated because bits of the engine were missing. And parts for these bikes are very hard to find. But the frame is an original frame, the rear end of the frame is missing, but the engine is, the bottom end is the original bottom end, but the cylinder head and barrel were very badly rusted. So we've actually bought from an Australian company, some recast cylinder barrel and head. So interestingly, the head is incorporated in the barrel. So it's got the cylinder head, part of the barrel with the two valve seats, and then there's a block bolted on the top which has the inlet and the exhaust port, and the valve guides are mounted on a block above the cylinder, but there is no head joint to leak. So the valves operate in the cylinder head from above, but the cylinder head is part of the barrel. So it's a blind cylinder head, which is quite useful from the point of view of reliability, but very difficult from the point of view of machining it, because obviously machining cylinder valve seats inside a closed cylinder head is a bit like building a Bugatti or a Bentley, because both Bugattis and Bentleys, as you probably know, have the cylinder head built into the top of the cylinder. You put the pistons into a Bentley and into a Bugatti from the bottom, because you can't take the head off, there is no head. So that's part of the design. And the attraction for me is that Halford clearly was fascinated by engines. You can see from the way he wrote up every single picture with the size and type of engine in the aircraft, which was more important to him than the make of the aircraft. But his experiences riding an overhead valve Jap engined Martin in 1913 clearly made him a fan of overhead valve engines. And all the engines, most of the engines he was working on, were either overhead valve or of that sort. And in fact, the gnome, famously, as you probably know, it was called the monosoupape gnome, which roughly translated means single valve gnome, because on the cylinder head of a gnome is only the exhaust valve, because the inlet valve is in the crown of the piston, because in a rotary engine like the gnome, the crankshaft is bolted to the airframe, and the engine rotates around the crankshaft, and the mixture goes into the engine through the hollow crankshaft. The carburetor is mounted behind the bulkhead and feeds mixture into the crankcase, and then the mixture goes into the cylinders through an automatic inlet valve which is mounted in the top of the piston. So the mixture passes into the cylinder when the piston travels down, and the mixture goes through the cylinder, through the piston's crown into the cylinder, and then when the piston starts travelling up, the automatic inlet valve closes and the mixture is compressed and fired, and then when the mixture is exhausted, there is a mechanical exhaust valve that allows the exhaust gas to release into the air. And of course, because the engine rotates, the engine is cooled by the rotation of the engine. Now, in the article that's in, there's a magazine, in fact I'll show you it here. The latest Brooklands bulletin has a picture on the cover of the Bob Dicker V-twin Rudge, which is another bike I've kind of been involved with down the years, because I was very involved in Rudge bikes and knew Brian Reynolds, who actually found this bike and then showed it to Bob Dicker, who was still alive, and brought it to Brooklands for Brooklands reunions maybe nearly 40 years ago. But in this article that I put together for the magazine, one of the pictures that's featured on the front page of the article. This actually is one of the aircraft that's featured in the albums, which is itself a bit of a curiosity. And I didn't mention it in the talk, partly because it's quite well written up in this article. But this engine looks like a Gnome rotary, but it has a very significant difference. It's actually a radial engine. So it's a fixed engine with a rotating crankshaft. And this is called an Isaacson engine. And Isaacson was an engineer who thought that the rotary engine was fundamentally flawed, partly because you can imagine rotating the whole engine was a bit of an engineering nightmare. So he took the internals of a Gnome rotary and he built a fixed engine with all the parts of a Gnome rotary, but the crankcase was bolted to the aircraft and the crankshaft had the propeller attached. And the Isaacson engine, with all the parts of a 50 horsepower Gnome, was rated at 60 horsepower. And that's quite interesting, A, because it shows that potentially the engine could develop more power if it was fixed rather than rotary. But two problems. First of all, it was, of course, a higher power output, so they were extracting more power. But unlike the rotary engine, the cooling was only the air flowing past the engine as the plane flew. So the airflow past the fixed engine was considerably less than the cooling effect of the engine spinning. So the rotary cooling effect of the engine spinning was a huge benefit. But the other problem was it was mechanically difficult because the entire setup of a rotary engine was designed around using what was effectively petrol. They added castor oil to lubricate the engine to the fuel. And famously, there was no throttle. All you had on the aircraft was on the pilot's stick, you had a cutout button. And when you see people flying rotary engine planes now, they start them, but they don't idle. They run full bore or not at all. So when you hear them running, and in between running, they cut the engines with the kill button on the control column. So as they fly the planes, as you're taxiing, you're essentially blipping the throttle. And you let the engine die almost to the point where it stops, and then let go of the button and it starts up again. And that provides essentially a throttling effect. But the real problem with a rotary engine is that the processional torque of the weight of the engine turning means that it's very, very hard. When you take off, you have this mass, which is a flywheel, running with the propeller, which creates a huge processional torque. And it means that when you're ground taxiing a rotary engine plane, you can only turn one way rather than the other way because the processional torque that comes from the engine prevents you effectively doing a tight loop, a tight circle in one direction or the other. It's usually that I think the left-hand turn is very difficult to do and the right-hand turn is very good. And you see endless shots of people taxiing rotary engine replicas that they fly now, places like Shuttleworth or the Rhinebeck, the old Rhinebeck, the flying field in New York State where they fly like they do at Shuttleworth, what are essentially replica planes with all the original technology. And you see them having great difficulty taxiing when the pilot chooses to turn the wrong way and they don't turn, and they go way off beam, and they have to be turned. Somebody has to go out and rescue them and turn them round by hand.
Martin, thanks for the talk. I think it's really, really interesting. If I can say on the rotary engine, effectively it becomes a two-stroke engine because, as you quite rightly said, you have oil mixed with the fuel to lubricate the cylinders. You're right, it's almost impossible to control the throttle. What you have is two levers, one is for the air, the other one is for the fuel.
Yes, you have an air control, yes.
And fuel.
Yes.
And so you need to make sure that you get the right mixture as you run in the engine so that it's not too lean or not too weak. And you're right, when you blip, you in fact are blipping the magnetos.
Yes.
So that you stop the camera and slow it down.
Yes. I mean, the HT lead on these engines is literally a piece of wire.
That's right.
It's not even insulated because it runs straight from the plug to the terminal of the magneto, effectively. It's really quite an interesting concept, the whole thing. It's quite miraculous that they work. But they're still there's still a number of original engines that are running and flying. And in fact, there's a famous guy, I think his name's Tim Moore, who's built a Thomas Morse Scout using an original Clerget engine. And it's a completely original First World War aircraft, which is running with essentially an original engine. And the engineering of these early engines is absolutely fabulous. Yeah. At the end of the war, there was a huge graveyard in France, in a village called Cleres, C-L-E-R-E-S, in northern France. And there was a guy called Jackie Pichon. And Jackie Pichon, at the end of the war, collected as many aircraft wrecks as he could, and he put them in his barn in Cleres. And Jackie Pichon's grandson, I think now, still runs this. Essentially, it's an aviation scrapyard business, supplying people with original First World War aero engine parts from the collection that his grandfather made, going around the airfield. Essentially the Western Front was littered with aviation wrecks, and many of them were brought back and rebuilt, but in fact many of them were just left and were recovered by people like Jackie Pichon's grandfather. And it's an amazing story, all these original engines that were supplied. And Cole Palin, who's the American enthusiast who set up the Rhinebeck field in America, he got many original engines for the aircraft that he created, and also the Shuttleworth. The Shuttleworth has a lot of engines that they are still running, which are original aircraft engines. Beautifully made, beautiful things.
I was very intelligent because Jackie Pichon did that big car collection as well.
Well, he had a car collection as well. He built a yeah. No, he did everything. He collected every kind of vehicle, and if you wanted interesting early parts for any early vehicle, then Cleres was a place you went to. And there's several other similar businesses. There's another business called Depan Auto, which is very close to where the Pichon yard at Cleres was. But I actually have had several early French vehicles, which came fortunately with all the original bits. And again, if you just put them back together, they work beautifully. I ran a 1912 Clement Bayard, which I found literally in a garage business in Cheltenham, which had been used as a breakdown truck for years and years and years, and then had started smoking so badly, they just pushed it into the back of the shed. And I restored it, and when I got it running, it produced clouds of white smoke. So I took it all apart and realised that the rings were so badly worn, I just put a set of new rings in and continued to run it with its original 1912 paintwork and original everything. And people used to say, aren't you going to restore it? And I said, no, I'm quite happy running it with its original paintwork, but it was all the original mechanicals as well. No idea how many miles it had done. And it's now in Northern Ireland with an enthusiast, and I said to him, I'm selling it to you on the understanding that you don't restore it, because if you restore it, you'll ruin much more than you'll improve. And he leaves it exactly as it is.
It would be very safe in Ireland, they don't destroy anything.
Well, very safe, yeah, indeed, yeah, very safe. But original things are so nice, which is what I love about Brooklands, because Brooklands is full of real original things being looked after by people who are not interested in what they're worth, they're interested in what they can do. And that's, to me, what it's all about. And essentially understanding what these people achieved in the time that they were working is much better if you actually have your hands on real machinery, which is the joy of this kind of place. And it's fantastic. Fantastic that it survived. And long may it go on surviving. So, okay.
Excellent, thank you.
Now at this point, can I say, Jeremy, if you'd like to come up and also Tony, and we can hand these albums over. Now these albums are going to be in the National Aerospace Library, which is in the Farnborough site, and it's a lovely place to go and visit. And Tony will, I don't know if you want to say a word about what the museum represents, but it's a fantastic collection of material.
Yeah, we are the Library and Archive of the Royal Aeronautical Society. So we've been around for 150 odd years and collecting stuff for 150 odd years. So we have got some of the amazing materials down from original sketchbooks of aircraft from the early years of the 20th century to the most up-to-date textbooks on aeronautics. our members, like Halford himself, who actually was our president at one point, collected lots of amazing material which they found safe harbour with us at first in London and now in Farnborough. And we're open Tuesdays and Wednesdays, and you're more than welcome to come around and see what we have.
But to have the albums and the diary together, because essentially the diary reports what Halford actually did day by day, and press cuttings of things he actually achieved, which were literally written about in the Flight, the two magazines of the day, Flight and the Aeroplane, were the sort of the Bible for the whole world, for the whole industry, and full of interesting adverts, but also interesting articles all about the people who were doing great things. And Brooklands was actually one of the most important places where the aviation world basically developed so much in the pre-First World War years. So the pre-First World War times, Brooklands were really big on aviation here, and it was equally as important as the track, even though of course everybody now thinks about the track and thinks about the Vickers factory that was here where they built Wellingtons and Halifaxes. So, which of course is also now revitalised by the fact that they moved the hangar where they were building Wellingtons off the track, which has revealed the start and finish straight again. So that was a nice development as well. But these are the two albums here. Jeremy? Yeah.
Haven't got that.
That's
very kind. Is somebody going to take a photograph to sort of record the event? I think we should have. I don't know whether our photographer here can do something with this, but perhaps. Yeah. No, that's fine. But it's brilliant. No, but Jeremy's come from Jersey today to actually be here to hand this over. It was all planned for October 2020, but unfortunately something called COVID came along, which rather knocked the whole plan for 6. So it's taken until now to actually get, it's now done. But I can assure you, Jeremy, that this will be cherished and will be loved, and will be detailed research will result, which is really what deserves to happen. Because although I've had them in my possession for a short period and have found them amazing, I hope I've conveyed some of the, you can't really do justice in an hour's chat, but it is an amazing story, isn't it? Yeah. Right. Thank you very much. There's also a book there, which is the letters that were written congratulating